Hello guys, hello world, hello Philippines. This is again, I am a singer, eternal voice. So at this moment in time, I will be able to continue my live stream topic that I did last night or yesterday with regards to common and basic formulas used in science that will be helpful and a tool for you to pass the Philippine Regulation Commission engineering examination, or shall we say board examination. Okay, so if you're listening to me right now, so have a blank sheet of paper and then try to dig it out. What are those basic formulas that will be used over and over again? Okay, because all higher subjects in engineering courses will always adopt this basic common science formulas. And the difficult thing and the complex thing will just be an additional. Okay, so we'll start on the most basic foundation, really, the most used and usable formulas in science and in mathematics also. Okay, we're talking about at least 30 basic formulas and equations, but there's also a lot. This is only based on my stock knowledge, acquired knowledge since elementary, high school, and college education. Okay, I tell you frankly, I did not find too much difficulty in my college because I memorized already the basic concepts when I was in elementary and in the high school. Okay, uh, when I won the chemistry quiz bowl, okay, in our school, in Naga National High School, that's the time I interest most of my knowledge focused on studying sciences, okay, not only chemistry. Okay, so shall we say that will be my driving force why I take up or why I took up Bachelor of Science in Chemical Engineering. Okay, so it's gonna be like that. Though I am not good in mathematics, really, that's true. I have average intelligent quotient for mathematics, but I can really uh, survive through acquired knowledge by having my own initiative, studying too much, practice problem solving, and go back to the theory also. For example, if we have in trigonometry, if we have Pythagora law, Pythagora theorem, then I have to investigate what's really about this, and I go to the very basic why that formula arrived. I will study how it derived from that. I will memorize also, but I will check how it is being derived to come up with that specific formula for the Pythagorean theorem is equals to like that as c squared is equals to square root of a squared plus b squared, and c is the hypotenuse, a is the base, and b is the height, something like that. Okay, so we need to understand, and then if we then c or hypotenuse equals to square root of blah 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 so on. Then we have to remember all the time for that, especially the right triangle, right? It's applicable in the right triangle. Okay? So we should remember about the Pythagora theorem or Pythagora law in trigonometry. I think so. Okay, so things like that we need to remember. It's being discussed already in high school. All we have to do is to develop that when we are in the college, especially your first year college, because it is expected that you have already the stock knowledge in chemistry, because in high school you are studying also chemistry. Take note for that. Though it is not very complex, what is being taught in high school, the physics and the chemistry, but you have still to adopt the basic foundations for that. And there's already a lot of formulas there, and still the same. You will be able to use that in your college. Okay, yes, it is. So the more you have adequate stock knowledge for the science formulas and mathematical formulas, the more you will enjoy and having more fun in your college days, especially if you are taking up engineering courses. Okay, it's true that if you want to become an engineer, build up your mathematical capability. It's true, but it's not really that a requirement. Okay, if you are really average in mathematics, that will do as long as you have the passion and commitment to study the basic formulas of mathematics, even though you are not good in mathematics, just like me. I'm not really good in mathematics, average only. Okay, average or a little bit above average, but not really high intelligent quotient. Okay, I develop more on the theories, concepts, and principles so that I can understand how to derive those equations and formulas, something like that, especially when my memory fails. Okay, now we have 30 formulas and equations here. So shout out pala to those chemical engineering that will be able to take up a PRC board examination this October 2021. Okay, you can listen a little bit also for me. Okay, for my confession also in the chemical engineering board examination, me before. Okay, so these are the compiled formulas to be used. Really, I will tell you, it's not really that difficult. Okay, what makes it difficult is that the combination and the compilation of a lot of formulas in one particular question. Okay, for example, if there's a question of unit operation, and then in that unit operation problem solving, a lot will be there. Okay, it's being mixed, the fluid, the gas, and sometimes you, oh my God, why like this? The ideal gas law will be mixed also to the fluid flow, something like that. And you should remember the theories for that because, for example, at the first stage, the water is liquid and it will become gas somewhere along the way at a certain assumption or a certain physical, if you boil that one, for example, right? If you boil that water and then it's undergoing a head of vaporization. Okay, heat vaporization meaning evaporation takes place, okay, from liquid phase to the gas phase. So even though you are treating that as a liquid in the initial stage, then you can be having it as a gas also somewhere along the way. Then you have to combine the ideal gas law, and there's a lot of gas laws equations, okay, especially for ideal gas law. And you have also to equate that to the fluid flow or the momentum transfer. There's a lot also, especially the Bernoulli theorem or the law of energy of conservation formulas. Okay, like that. And you need to memorize class ha the what is really the law of conservation of mass, the law of conservation of energy. You have to memorize and to understand what's that all about because you will always be using that one when you go to higher chemistry, higher engineering subjects, or let's say science subjects, especially physical chemistry, unit processes, unit operations, shun a lot, crystallization, sedimentation, flotation, leaching, distillation, heat transfer, mass transfer, momentum transfer, a lot of physical and chemical separation processes, especially also the reaction kinetics. Okay, or the chemical reaction engineering, dealing with too much concentrations of different three phases of matter, could it be solid, liquid, and gas? Okay, something like that. You have to have a very big perspective or take a look into a big picture of what is really you are studying into it. Okay, so do not limit yourself to your instructor and professor. Really explore even more. Okay, that's the second technique. Okay. First technique, memorize all the basic science formulas. Number two, dig more. Okay, uh, go to library every vacant time. Okay, because you cannot understand sometimes also if there are terms that you cannot understand very well, and you can refer to the different books in the library also. Okay, so there's a lot of presentation and styles of how it is being discussed. For example, if you cannot understand very well how your instructor will discuss, and then you will go to the library and borrow a book, and then sometimes there are books also that very good in presenting their discussion. You can really understand easily. Okay, pick book A, book B, book C, book D, and you can also troubleshoot that the books are not the same. They are presenting the discussion in different manners also, but they can always obtain the same answers and the same theories and principles, but only the delivery and their discussion in the pages are a little bit, not the same. Okay, especially the symbols. Symbols are very important, okay, in science and also in mathematics. Okay, the Greek symbol. Okay, especially because our scientists before are usually on the Greece, Greece. So that's why we use Greek symbol, alpha, omega, rho, ganun siya. Okay, beta. Okay, so don't forget also for that. Okay, and now we go to this. Mag-start na ta. Okay, number one. This is not in particular order, ha? This is only based on my stock knowledge accumulated in my brain cells. Okay, number one, mass flow rate. Oh my gosh. So mass flow rate is very applicable in the continuity equation or the continuity law. So in here, most of the times we are referring to a steady state flow, usually laminar flow. Okay, not really much in turbulent flow, because in turbulent flow you cannot expect that there's an equilibrium stage or steady state, because you know the movement of fluid and liquid are very fast, chaotic, chaos, okay, so erratic, so random, like that, so it becomes turbulent. Okay, the movement is so fast. That's why it developed an EDs, ADDIES, somewhere along the way, if the turbulent flow will be there. And now for the laminar, it's very uniform, like that, okay? Slow, and then very, very uniform and steady state. So that in here, we will apply the mass flow rate, okay, by adapting the theory and principles or law of conservation of energy. Okay, now we go back to mass flow rate. Okay, mass flow rate is equals to density times the area times the velocity. Okay, don't be confused also with the velocity and the speed. Okay, it has the same unit, meter per second, feet per second, but it's just the same. Okay, but in here dealing with especially chemical engineering, momentum transfer, like that, we are referring to velocity as a vector quantity. Velocity because we are concerned with the direction. Okay, the direction where it goes from point A to point C to point B to point D. But speed never concerned too much about the direction. Okay, so this velocity is a vector quantity. Okay, meaning the direction is very important. For example, it flows from a higher temperature to lower temperature. It flows to a higher molecular movement to a lesser molecular movement. It flows from a higher temperature to lower temperature. It flows from higher concentration to lower concentration. It flows from the east to the west, to the north, to the south, like that, blah, 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 so on. So the direction is very important. That's why we use velocity here, not the speed. Okay, though it has the same concept and unit. Okay, like that. Speed mostly used in the motion of a car or a truck in the main road or the road. That's applicable in physics. Okay, apply there. But in the here in the chemical engineering side, it's not like that. It's not limited to objects movement and motion. It's about fluid, liquid, gas. Okay, so that's why we use velocity instead of speed. Okay, like that. So kph, okay, mph, okay, kilometer per hour, okay, like that. So it's different, okay, but the concept will still be the same, okay, like that. So density, area times velocity. So the unit will be in kilogram per second. Watch number one. Okay, kilogram per second class, or it could be pound per second, gallon per second, liter per second, cubic meter per second, something like that, huh? Cubic meter per second, okay, like that. So that the mass flow rate, okay, kilogram. Basta siya, the numerator is always mass because this is mass flow rate. Okay, ganun siya. So, for example, if there is a fluid that will go to the particular, for example, venturimeter, okay, orifice meter, or pipeline, or let's say cylindrical pipeline, or tank, or whatever, tuba, then you can use this formula. Okay, 0.1, 0.2, 0.3, 0.4, 0.5, because the fluid will travel from 0.1 to 0.2, 0.3, 0.4. So use the continuity equation, but by applying the mass flow rate. So mass flow rate of 0.1 is equal to mass flow rate of 0.2. Mass flow rate of 0.2 is equal to mass flow rate of 0.3, like that. So, but applying the assumption that it is a steady state flow, okay? It is a steady state flow in equilibrium stage somewhere along the point, so that you can easily get what is being required. For example, you will ask, what is the diameter of the pipe if the fluid will go to like this? You can, especially if there's velocity, then you can compute for the diameter. right? So it's gonna be like that. So we can compute for the velocity if there's an area, a diameter, okay? Because the density will always be the same all throughout the point A, point B, point C, and point D. For example, especially water. Water is having a density of 1,000 kilogram per cubic meter, okay, 1 gram per ml, 1 gram per cc at 4 degrees Celsius. Okay, you can write that in the piece of paper. Okay, so this is very basic. Okay, class. Okay, in a problem solving, sometimes they will never mention the value already. Okay, like that only. The water will flow in the cylindrical tank to a velocity of like this, with a height like this, and a vertical distance like this, and the diameter or the radius. What is ganun siya? Find the mass flow rate of this fluid when it goes out to the outlet. Okay, something like that. Then you have to remember the density is always constant all throughout. It will never change that much. Okay, it's not an issue in a laminar flow. In a steady state flow, the density changes. Okay, unless it is a turbulent flow. There's a relevance, or shall we say, it would be an issue for the density changes, or this density variance or density gradient. Here we assume that the density is just all throughout just the same, especially the water behavior. Okay, like that. Okay. For example, in examination, the examination will say, what is the temperature when we have a density of water which is equals to 1,000 kilogram per cubic meter? A, 5 degrees Celsius. C, D, 7 degrees Celsius. C, 8 degrees Celsius. D, 10 degrees Celsius. So you can answer that it's 4 degrees Celsius because you memorize it already. Okay, it's in your brain cells. Okay, again, when we obtain a standard of 1,000 kilogram per cubic meter, 1 gram per ml, and 1 gram per cc, the density of water, pure substance, water is a pure substance, that means at 4 degrees Celsius. If the temperature is not mentioned, then use that density automatically because that is water. Now, if the temperature is mentioned there, do not use the 1,000 kilogram cubic per meter. It's another story. Okay, because the density is dependent on the temperature and the pressure. Go to the Paris Chemical Engineer Handbook, chemistry textbooks, or physics textbooks. Go there and find the value of the density at 25 degrees Celsius, at 80 degrees Celsius, because this 1,000 kilogram per cubic meter will no longer be applied. Okay, like that. For example, a water flow at 30 degrees Celsius, like this, blah, 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 and a velocity like that. What is the mass flow rate when it will go to the tank or process tank? Okay. So you will never use even though that is water, you'll never use already the 1,000 kilogram per cubic meter. Okay, like that. Okay, so just remember, we are very, very lucky class if the problem is always water. Okay, but if it is an organic liquid, an inorganic liquid, and another substance, then it is not easy to put that data in the equation. Okay, so you have to scan your handbook, the textbook, like that, or you can memorize the basic one only for the alcohol, like that. What else? Basic alcohol, gasoline, kerosene, oil, something like that, at 4 degrees Celsius. Because 4 degrees Celsius is always our reference temperature to make it standard. Okay? 4 degrees Celsius. So if there is 4 degrees Celsius value of water, of course, there's also value for another liquids at 4 degrees Celsius. So better memorize already at 4 degrees Celsius so that you will never scan the books because it's just be the same. Okay? Or you can do the interpolation. Okay, interpolation, because you have already the value of the water, then interpolate that to the other liquid. Or shall we say ratio and proportion? But sometimes also ratio and proportion will fail. Okay, so you go back really to the handbook, the textbook, like that, blah, 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 so and so. Okay, because not all the time will be memorized. Because there's a lot. How can we memorize all those concepts, by the way, in the first place? Okay, number 2. Okay, volumetric flow rate. Okay, so the problem in fluid flow, fluid dynamics, fluid statics, Okay, in fluid mechanics or the momentum transfer, it's always flow like that. Now it could either be a mass flow rate or a volumetric flow rate. Now you should put that in your brain cells that volumetric flow, there are only two quantities involved. We drop the density quantity. Okay, so we have already the area and velocity on E. Okay, so the more it is easier compared to the mass flow rate. Again, in volumetric flow rate, we drop the density in the formula. It's only the area times the velocity. So it simpler or simplified compared to the mass flow rate. So a volumetric flow rate is equal to the area times the velocity. Okay, the area is the cross-sectional area. Okay, for example, if it is a pipe, then it's round, right? Round. So we'll be using pi d squared over 4, the cross-sectional area. Or you can use also the pi r squared for the area if the radius will be given. Or actually, if the radius will be given, you can convert to diameter because diameter is also 2 times radius, right? So it's up to you. If you will use the pi d squared over 4 or you will use the pi r squared. Okay, for the round a diameter for the pipe. All of them are round. It's impossible that the pipeline are, rhombus, trapezoid, rectangle. Okay, it's always round. Tank also is a round. So most of them are round inlet and round outlet. So that's why this kind of area will be applicable. Okay, if there is also a cylindrical, another, for example, a sphere. Okay, the volume of a sphere is different also. That is a 4/3 pi r cube, right? If you remember, differential calculus, I think so. Correct me if I'm wrong. 4/3 pi r cube is the volume of the, the volume of a sphere, S-P-H-E-R-E. Correct ba? Basta, okay? That's why I'm remembering, okay, and stuck in my brain cells. Okay, 4/3 pi r cube is the volume of a sphere. Am I correct? Never mind. Okay, correct me if I'm wrong. Okay, so that's it. Okay, we also matters the shape, shape, because it's in there you will determine if it is applicable or not. Especially with dealing with area. Okay, the dimension, blah blah blah, so on. So because in the rectangular, the surface area is another thing also, length times width. O ganon. Okay, so just like a rectangle or the triangle, whatever you want. Okay, shapes matters a lot in studying geometry or trigonometry. Okay, so this is volumetric flow. So your unit class will be, okay, I'll show you. Okay, cubic meter per second. Okay, cubic centimeter per second, liter per second, gallon per second, or anything that has a volumetric quantity, volume. Okay, so it is cubic meter, guys, because the sides of the volume are just equal. That's why it is sides raised to the power 3. Actually, that is side times side times side, or length times length times length. So L raised to the power 3 or S raised to the power 3. And if there is value of that side and length, so that's why it's cubic meter like that, cubic centimeter like that. Okay, just like a cube, ice cube. Okay, so it is equal over the length, the width, something like that, and the height. So you will raise to the power 3. Okay, so for example, we let S as the value of the side of that cube. So S raised to the power 3. So if we let S as 2 meters, so substitute the 2 in S, so 2 raised to the power 3. So that is 8 cubic meter. Okay, that's in case in the cube, volume for a cube. But for another thing, is not like that. Okay, because you have also volume is equal to length times width times thickness. Okay, and if it changes, so it changes. So do not use always all the time that principle. Okay, it depends on the situation. Okay, like that. Okay, number 3, heat. I love heat. Oh, this is very important in our daily lives. Okay, we have the metabolic cycle. As an individual, we have our metabolism, right? To break down large macromolecules into smaller molecules, micromolecules. Okay, so macro meaning protein, let's say nucleic acid, carbohydrates, like that. Okay, the vitamins, the minerals, blah blah blah, so and so, and then for the micromolecules, they have the converted into toxins, residues, or any the breakdown of those large molecules into smaller molecules. We are undergoing the process of metabolism, and heat is a driving force during metabolism. Okay, so we will take into account that we have the main organs inside our body in our physiological parts or the anatomy structure inside our body. So we have the liver, right? The liver will filter all those foods. Okay, it will filter the toxins or any harmful substances. Okay, including the fatty acids. Okay, he will deliver, he or she, this liver, will release these fatty acids into the bloodstream. Okay, when it releases into the bloodstream, it will go in different organs in our body. Okay, like that. And then these fatty acids, okay, will be used as a fuel, fuel to heat up these muscles and tissues in our body so that we'll become strong. In that time, we will become energized. We have the energy. So that will be used as a fuel to drive the metabolism, okay, and support function. That's why we will walk, we will eat, we will run, we can do our job. So the fatty acids are responsible, okay, for that. That's why we need to eat foods that contains fat. Or else, if we don't have fat, we don't have fuel in our body. Just like a gasoline used in the car. How can the car move if there's no gasoline? It's just the same story like that. How can we move if we don't have fats or fatty acids? Because it will act as a fuel to drive our metabolism, to release heat in the environment. Okay? Heat in. Upon releasing the heat, through movement, workout, walking like that, and then we burn calories. Okay, we burn those fatty substances, any substances coming into our body. So that's very useful. The heat. Okay, that's not only applied to the processes in different chemical process industries, plants, metallurgical plant, power plant, petrochemical plant, cement plant. That's only not limited only to that this heat concept. It's also applicable in our body, in our health immune system. That's why I love heat. Charot. Okay, heat. So the formula of heat is Q is equals to mcpdt. So by the way, class, if the problem also in the board examination are dealing with substances and then it asks for the heat, you can compute. Okay, for example, the mass of a protein, the will go to your esophagus and reach to your intestines, like that. The temperature of your intestines, like this, blah, blah, blah. Okay, and then blah, blah, blah. Okay, what is the heat capacity of of these molecules coming in your body? So you can compute because there's a formula Q is equals to mcpdt. Okay, so you will just know what is the mass of the food you eat, the mass. For example, I eat kabush. What is the mass of the kabush? Okay, I will have the weighing platform. Okay, 2 kilogram. Okay, I will put there in this equation. Ganon. The temperature. So if I have the thermometer, I will check the temperature of the kabush. Okay, the food I ate, like that. My only problem now is the specific heat capacity. But take note, the specific heat capacity of the kabush will be in equilibrium to the water we intake. Okay, because the kabush will go inside our body. Okay, will react to the water. So let's assume that the specific heat capacity of kabush, the food, is equal to the heat capacity of the water, which is 1 calorie per gram degree Celsius. And bingo, we can determine the heat of the kabush inside our body, how much heat is being absorbed, consumed, released, blah, 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 so on. So anything can be computed. Okay, what's coming in, what's coming out. This in the process plants, what coming in, what coming out. My point is it's not limited only to plant, to companies, to factories. It can also be applied in our immune health system. This concept about heat, H-E-A-T. Okay, this is Q is equals to mcp dt. Okay, because it is applicable also in different phases of matter, solid, liquid, and gas. Okay, class. Now, if we are dealing with heat, so that is thermal, right? Thermal. So meaning to say, we need also to study a little bit of basic thermodynamics in here. I'm not telling you to go over the detail of thermodynamics. Just go to the first law of thermodynamics and the zero law of thermodynamics. It's there. It's being discussed properly. The basic concept of computation of heat. Okay, like that. So it's gonna be heat absorbed and heat released always, all the time. Okay, that's why we have a negative heat. That means the environment is cold. If that happens, we have an endothermic environment. Okay, meaning to say the heat is being absorbed and consumed. So that's like that, blah, 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 so and so. Okay, so it becomes colder now. Colder, cold, or the temperature is reducing, reduced temperature. So endothermic reaction, negative heat. Positive heat is releasing of heat. Heat is given off and heat is being exposed to the environment. So we have an exothermic environment or exothermic reaction. So it's very hot in our environment. Then we need air, cold air, and we need to put AC in our room because I have an exothermic environment. Okay, something like that. So we need an AC to cool, COOL. Okay, so that's the purpose. Okay, like this to have a cooling system, equilibrium between the heat and the cold. Okay, cooling system and heating system must be balanced all throughout our body. You understand? It should be balanced so that our immune system can really survive. Okay, so what is being absorbed, what is being released must be equal in a steady state equilibrium in our body or something like that. So Q is equal to MC P dt. Mass is the mass of an object or anything, right? Cp is the specific heat capacity. Look for this. Cp is the specific heat capacity or the heat capacity or the specific heat. It depends on the how the books presented, and how your instructor discussed this Cp. Okay, the specific heat capacity, or heat capacity. Okay, but the unit will always be common unit is 1 calorie per gram degree Celsius. So it depends also because there's a lot of unit of energy. Okay, calorie is energy, and heat in the first place is an energy. Heat energy, the same as chemical energy, light energy, thermal energy, or there are at least 12 energies occur in the planet Earth. So if you are taking engineering courses, especially chemical engineering, memorize all. Okay, what are the concepts for that? Admittedly, I memorized about that also when I took the board examination. I troubleshoot what are those energies, I memorized the definitions, and I also memorized all the definitions of chemical separation processes so that I have an ideas and concepts and principles to be backed up when I solve the problem solving. It's not enough you keep on solving problems, then you are having less theories and principles. You cannot really understand if the problems are already complex because you don't back up with theories. Okay, so that's the tool, that's a technique. Okay, that's a technique if you want to take chemical engineering board examination, electrical engineering board examination, mechanical engineering board examination, or engineering board examination. Please, 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 class, go to the most basic foundation concepts and theories of science and mathematics. It will help really a lot. Okay, even though you will not practice the difficult problem solving, you can still answer properly. Okay, admittedly, there are difficult questions, problem solving, but there are a lot of theories also. Okay, it should be balanced. I think it's only 30% difficult. Something now, bingo, if you have 70% already answered well, then it's impossible out of the 30% difficult problem, so you can never solve. So at least you can solve at least 10%, then bingo, you will pass. Okay, the same story with the general engineering, physical and chemical principles, and the chemical engineering. Our major is chemical engineering. If you're taking electrical engineering, your major also is electrical engineering, but the same. You have also general engineering in your day one, or let's say in your day two examination. The same with us also. We have general engineering. All engineering courses have general engineering coverage in the board examination. Okay, so that's why that's the point there. Okay, so that's why if you are really, bulakbol in high school or barkadista, and then you'll never learn a lot in high school, you will suffer really in college. Okay, even though how much you tried in college, because it should be stacked supposedly in your brain cells. Okay, this all. Okay, this 30 concepts are already discussed a little bit also in high school. Okay, but not really that digging more. It's in college you will dig it more. Okay, but if you really memorize the basic one, and then when you go to college, then there will be no problem at all that much. Okay, I'm saying you that much because admittedly there are a lot of mathematics and engineering. Okay, we have algebra, trigonometry, geometry, probability and statistics. Okay, integral calculus, differential equation, advanced engineering mathematics. Okay, like that. So there are 9 or 10. Okay, mathematics, and the most difficult I think so is the advanced engineering mathematics. Okay, but the problem solving doesn't require all the time those kind of integral, differential. That's only alternative. Okay, but we go back to the basic, which is algebra. Okay, because all problems can be solved by algebra alone. Okay, take note, there are problems can be solved with integral calculus application. There are also problems can be solved in differential calculus application or differential equation. Take note, if you use also algebra method of approach of the solution, it's still the same answer. Okay, so I will rather use this algebra rather with this three because this is more complex. Okay, we have to memorize a little bit. For example, differential calculus D1, D25, integral calculus I1 to I25. How about using algebra? It's very basic, right? Using only four mathematical operations, which is subtraction, division, multiplication, ganon. So I will use algebra. Okay, of course. And it will yield the same answer. So why you complicate yourself? Unless it is general engineering, of course, you will use that there, separate, separate coverage in the board examination. Of course, you will need to integrate if it is integral calculus question. You need to differentiate if it is a differential calculus problem. Okay. What I mean, there are problem solvings that can be really solved by algebra alone without taking into consideration the differential like this. That's only an alternative, okay? Another way of solving so that the students will learn another method how to solve the problem, okay? That's only the purpose behind. And you can never also use that integral differential calculus in the real world, okay? It's always the four basic mathematical operations will be used kung nagtrabaho na ka or you are in the actual field in your profession. It's not integral calculus all the time, like blah, blah, blah. It will only be used in the designing stage, engineering design. It could not be denied. There's a little bit of integral calculus, differential calculus, and differential equation, like that. A sort of like that in the designing of an equipment, designing of a machine, designing of a plant or plant design or whatever, it's in there that you will be used. That, but in the actual field of work, you will never use that. I will integrate this to get this volume. No, you'll never do that. Sure, 101%. Okay, even in the laboratory, when I work in the Coca-Cola Bottlers Philippines Incorporated, Tagbilaran, I am in the quality assurance department. I am the product quality engineer there. Okay, we don't integrate, differentiate. It's always for basic mathematics operation. Okay, like that. I tell you frankly and honestly. Okay, just study it for the purpose of learning it and to pass your subjects and then to pass the board examination like that. But in the real world, it will never be applied most of the times. It's only in the design stage it will be applied, but not also too much. Okay, like that. Okay. I'm not telling you I discourage you to study integral differential like that. I'm only telling you the truth that the basic mathematical operations, algebra will be used all the time. Okay? And I'm not also telling you because I'm not good in mathematics. That's why I'm telling you that we goes back to this attack. I'm telling you the reality. Okay? Whether you are good in mathematics or not. Okay? Like that. So number 3 is the heat. This one. Okay, guys. Heat. Okay. Heat absorbed. Heat released. Heat consumed. Heat was given off. Okay, like that. So energy, heat energy or thermal energy. So it governs by the changes in temperature. Always, it's a heat. Okay. Now, guys, memorize this 4 formulas of temperature so that you will never be dependent on the book. Okay. Me, honestly, I memorized this when I was in high school. Take note, when I was still in high school, I memorized this. Okay, not in college. So that's why in college, I did not find difficulty too much in this temperatures thing. Okay, so degrees Celsius, memorize. Okay, 5/9 times the close and open parenthesis bracket degrees Fahrenheit minus 32. Now put that in your brain cells that if that is a degree Celsius, that is less. So that is 5/9. Okay, less. And then minus. Okay, like that. So bingo, you can memorize that. Even though you will reach 60 years old, 70 years old, you will never forget that formula. Okay. Okay, so that was 30 years ago. I can still remember the formula of degrees Celsius until now. Okay, so degrees Fahrenheit is equal to the bigger one. So 9/5. Okay, it's in there that you will take note the addition or the plus. Okay, so 9/5 times degrees Celsius plus 32. Take note always 32 in the end. And then bingo, you can memorize immediately. Okay, because minus 32 plus 32 and small and big like that. Your identification only so that you can memorize properly. Okay, okay. Degrees Rankine. So you'll take note that the degrees Rankine is always multiply only. So 1.8 times Kelvin. Okay, no other thing. No addition, no subtraction, no fraction. Okay, so it's very easy. So Rankine, 1.8 times Kelvin. Memorize that. If you're a student right now, first year student, engineering student, memorize. That's gonna be like that. Rankine is equal to 1.8 times Kelvin. And Kelvin is not degrees Kelvin, it's always Kelvin. Huh? This is only the difference from the Celsius, Fahrenheit, and the Rankine. Okay? And now we go to Kelvin. Kelvin is equal to degrees Celsius plus 273. Okay, take note that this is only addition also, no other thing. Okay, it's very easy to identify, right? If you talk about Kelvin, addition only. Okay, so degrees Celsius plus 273. Rankine, only multiplication. So 1.8 times Kelvin. Celsius, we need to have two minus or plus, it depends, but we need to understand that the Celsius is lesser fraction. So 5/9 times degree Fahrenheit minus 32. Okay, copy in your brain. Okay, degrees Fahrenheit, bigger fraction, so 9/5, and then there's also a 32, and then so there's plus. Okay, so 9/5 times degrees Celsius plus 32, and bingo, memorize these four formulas of temperature, and then you can easily solve for the heat absorbed and heat released, something like that. And it depends on your analysis only, how you give attack to the problem that will come out in the board examination or any type of examination. That's analysis already. Okay, but at least you have the memorization first, how you understand the formulas, and then your analysis will vary kasi there's a problem. Your analysis will vary on the type of problems that it will be presented in the examination, something like that. So if you have a higher IQ, then you can really answer fast compared to those lower IQ, right? Especially when we talk about analysis. But never mind, just be patient, be initiative, try to be resourceful, because me, I'm not good in mathematics, then I passed, right? Okay, so Q is equals to mCp dt. And then the Cp is a specific heat, ha? Okay, calorie per gram degree Celsius. Remember that one, ha? Because in specific heat and heat capacity, there always be an energy, unit of energy in the numerator. Okay, class. So, Sir Sotero, what are the units of energy? I will discuss this to you. Get a sheet of paper and take it down. Joule. Okay? Like that. It's gonna be like that, in studying. You will take the possibilities of all the units. Like, do not stick on one unit, please. Okay? Because in the problem solving, it will be varying all the time. And no more time to scanning like that. What's the value of this? To like memorize. Okay? Joule. Okay, joule is equal to Newton meter. Okay, calorie. Okay, kilocalorie. BTU, British thermal unit. Okay, and erg. Erg is dyne centimeter. This is unfamiliar because if it is unfamiliar, the more it will come out to the examination. Okay, because it will help the students to analyze that there are still another units for that. Because we are only used to for this calorie, for the joules. That's why they give another unit to really test and measure your intelligence level or comprehension level or analysis level or how resourceful you are when you are still student. something like that. Erg is equals to dyne centimeter. This is erg is a unit of energy. Okay, and then it goes back also to the definition. Work is the capacity to do work. Work is the capacity to do work. Something like energy is the capacity to do work. Sorry for that. Work is equal to energy. Okay, my brain self-detect that work is always equal to energy. That's why my definition have always worked. But actually that is energy is the capacity to do work and energy is the ability to do work. Okay, like that. So memorize. Okay, like this it's equal. Even though the formula is just work is equals to force times distance, then you can say also capital E is equals to force times distance because of the definition that energy is the capacity to do work. Okay, like that. So when your memory fails, especially me most of the times, go back to the analysis, okay? Like that. As long as you have this basic concepts, okay? That is heat equals to Q is equals to mCp dt. Number 4, energy. Oh, I love energy. My God. So take note the law of conservation of energy. Okay, if you are listening well to your chemistry instructors and professors, we discuss well what is really the law of conservation of energy, the law of conservation of mass. Okay, like that. The law of conservation of mass is more on the stoichiometric relationship that will be used in the chemical calculations, right? And will be used in also in the energy and overall material balances, right? In unit operations and sometimes also in kinetics, chemical reaction kinetics, and also in the thermodynamics. Okay, the law of conservation of mass. Same as law of conservation of energy, but the law of conservation of energy are applying the different pressures. Okay, the hydrostatic pressure, the dynamic pressure, okay, or the static pressure. Wow, we know only one pressure, but you have to identify also that there's a lot of pressure. Okay, we have also atmospheric pressure, gauge pressure, absolute pressure, vacuum pressure, and bingo. If you know that, there's a lot of pressure questions also in the board examination. Okay, then you can answer well. Unless it is being stated in a very difficult manner. Okay, that's why the students will be, panic and, rattle. Because, oh my God, I did not read this before. Okay. Because the question was like, calculate the vacuum pressure of this blah, blah, blah. But in our study in the college, they will never a question like that all the time. It's not going there. Okay. And then what is the absolute pressure? Absolute is there. It's also discussed. But sometimes vacuum pressure is not really that issue in the college. You will never ask that most of the times. Okay, but in the board examination, it will come out. What is the absolute, the vacuum pressure of this? And you don't have an idea that this vacuum pressure is very important, in the same as atmospheric pressure, okay, and absolute pressure. Okay, what is the formula of this vacuum pressure? Okay, just take note that this vacuum pressure plus the gauge pressure is equal to the atmospheric pressure. It is the pressure below sea level. Okay, like that. That's why it's not also used all the time because it's below sea level man siya. So we are concentrated on the above atmospheric level man siya. Okay, which is the atmospheric pressure. Okay, like that's gonna be like that. Later we will discuss about pressures also. Okay, so that is heat is equals to mass times heat capacity, that is change in temperature. I'm only discussing the basic, I will never go to the integration part, okay, the differentiation part, or involving differential equation. I will never do that, okay? So number 5, we have power. Oh my gosh. Power. Sa ganitong power, oh, you have a powerful voice. Charot. Okay. So, power. My gosh, if you talk about power class, guys, this is very important in dealing with electricity. Okay? That's why we have power sources. Electricity, guys, you need to remember the Ohm's law. Okay? The voltage, current, and resistance relationship. Okay? Put that in your brain cells also, because in the examination, it's always come out also, even though in a very basic examination. I remember when I take or I talk the chemistry quiz ball before, okay, in University of San Carlos, okay, because I represented my school before, because I I'm not arrogant, I'm just telling the truth. I won the chemistry quiz bowl in our school. Okay? And I represented our school to join that quiz bowl. And I did not win. Okay? Okay. Like that. Okay? So, here it is. Okay, power. Power is equals to work over time. And you know that, I already showed to you the formula of work is equals to force times distance. Okay, ganun na siya. Okay, connecting the dots. Okay, be patient, be resourceful, initiative counts a lot. Okay, and then thorough and adequate preparation. Just like this, okay, I'm doing my blogging, my live streaming. I'm not taking board examination. I'm not taking an examination, but why do this? Okay, so meaning to say, I want to further enhance my knowledge, even though I am now already an engineer. I still have to enhance and to gauge my knowledge regarding in science and mathematics because the world is not stagnant. Maybe after this, I will be going to another countries to teach, like that. For example, there's an offer of subjects to teach in, in America or whatever. After taking my masteral course, then I can do teaching profession also. So it's not limited. So for now, I'm working as a teacher, but who knows? Okay, like that. So we cannot really troubleshoot what's gonna be our future, something like that. Okay, because I love really, this kind of thing. Okay, that's why I shifted to safety because safety is a lot of trainings. Okay, then you can deliver your knowledge to anybody else. And I love sharing of information. Okay, that's why. Okay, that's number 5, power. Okay. Okay, class, the revenue is only a secondary revenue, right? I have my channel, I have my YT channel, and my revenue is rising every day, to be honest. Okay, it's rising every day. And then after a month, it's also rising. Okay, and it's confidential. I'll never tell to you what's the value for that. That's in terms of dollars. Okay, so that's why I make a lot of videos. Aside from that, really, my main purpose really is to share information. Secondary, only the revenue. Okay, so like that. I don't want to aim to become rich just because of this. I want also to share information, and I want also to refresh my knowledge. 30 years ago or 25 to 30 years ago, something like that, and it recalls what are my psychology before, and I still have to discuss to you guys, and then a little bit of research. Okay, exploration, read, especially if I failed on my memory before, because I'm very old now. Very talaga. Okay, I'm old now. So when you are getting old, it's expected that your collagen protein will drop. And your tissues and muscles will not also be stronger compared in your younger stage. And also your brain cells is not very strong compared as before. Okay, so it's dependent on the age also. Your intelligence matters also in the age. Aside from the genetic factor, okay, for example, if your family is really not having intelligence, then the rest of your family roots are also good academically. Aside from that, the age also will vary for the intelligence. Okay, as you grow older, your intelligence will become lower. Okay, that's why if you want really to expand and enhance your knowledge, then you have to do a lot of efforts by researching, reading, exploring. Like that, you have to balance your time. Okay, just like this. Okay, means to say I do this, but I can also still watch movie. I can still also watch politics. Okay, sports, singing. I do this because I need to improve my, my channel, YT channel, and I need to have revenues all the time. Okay, like that. So this is a commitment, passion, and dedication. Okay, just like into a relationship, you have a commitment and passion and dedication, and you still give this time. Okay, and who knows, after 2 years, 3 years, and 5 years, okay, it will grow my revenues. Okay, brother, that's one. So, and who knows, there is one video will become viral and trending. Okay, because we cannot predict the future. Only God can predict the future. Okay, and nobody else. Okay. Okay, number 5, power. Okay. Power is equals to work over time. Oh my gosh. So it's discussed in physics, right? If you can remember, physics. We have a lot of physics in our college. Okay, we have 4 semesters, I think so. We have physics lecture, physics laboratory, and then another physics 2, and another laboratory, something like that. Okay, so this is power is equals to work over time. And then the work class, okay, there's a lot of formula of work, right? Okay, let's touch item number 5 and number 6 directly, because it talks about power and work. Okay, so power. So if you will forget the unit of power, just insert the unit individually in the quantity of the numerator and the quantity of the denominator. Okay, work. What is the unit of work? The most common one is joule. G-O-U-L. Joule. Ibutang rin mo siya. So joule over second, because it is time. Joule over second. Okay. Hi, Mr. Web Channel. Hi. Okay. I will say hi in the chat screen. Oh my God. Thank you so much for passing by with this academic information pertaining to basic formulas in science that will be used in engineering examination or board examination. Okay. Hi. Hello. Hello, Mr. Web Channel. Oh my gosh. Okay. Thank you for passing by in my live stream. Oh my God. Thank you so much. Okay. Now, joules per second. And think of a unit also that is equal for joules per second. What's that? Think. Physics in your high school. Last year of your high school, you can remember the formula of this also. As I told you, keep in memorizing topics in high school because it will be used in college. Okay. Power, the unit of power is watts. Okay, watts. And 1 joule per second is equal to what? Okay. Is equals to what? Watt lang siya, YS kasi singular man siya. Okay? Watt is equals to joules per second. Okay? Now, if the problem in the examination will state, what is the work in joule if there is a resistance of like this flowing in the wire? Okay? Somewhat like an electricity problem solving. And then you will be afraid because what is joule? And then you are used to taking the watts only. Okay, you understand the point? Because you are most of the time using the watts only in the example of your instructors and your professors. And you'll never research that there's another unit for the power. So it is in here that you will got wrong. Okay? Because no more time to scan the pages of the books in the examination. It will take a time for just only one problem. It's very easy problem. Only asking what is the number of joules in that particular wire that has a current of blah, 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 so and so. Okay? And then your idea only that watts is the power, no other thing. Well, this is the example of stock knowledge works. So even though it's not stated in watts or in horsepower, you can still answer because 1 watt is equal to joules per second. And the question is asking for joules man siya because joules is the unit of work. Okay? And the formula of power is equals to work over time. So bingo, you can solve the value of work in terms of joules, though it is not in terms of watts and horsepower that you are used to most of the time. Okay? That's it. Okay, that's the trick there. Okay? So now it's applying horsepower. So 1 horsepower is equals to 746 watts. Okay, so this is applicable for motor, right? Motor pump in the plant process areas or whatever factories or or power plants or whatever. So motor pump is very important, right? To give energy, okay, mechanical energy and then producing electrical energy to power those work equipment, process equipment, blah blah blah. So we have 1 horsepower, 2 horsepower, and then that is also equal to watts. You will solve that because you have 1 horsepower is equals to 746 watts. Okay, so from watts going to joules per second, so you can answer really. Okay, since we have a lot of energy units here, BTU, British Thermal Unit, erg, calories, kilocalories, and joules. So we have also 1 calorie is equals to 4.184 joules. 1 calorie, 4.184 joules. So it is also possible that the question will say, how many calories will be obtained if the current will pass on the wire like this in terms of ampere and in 10 seconds? And you will be shocked also, what's calorie? Calorie is only applied in the heat, but you can still solve because calorie is a unit of work and power is supposed to work over time. Don't be afraid that the unit is a little bit strange in your eyes and because you are not using that all the time. Okay, calorie also is work, the same with joules and the same with like this, and you can also have watts and horsepower. Okay, it's just the same. Okay, so calorie per second. Wow, calorie per second. So that would be equal also your power because work over time and siya. Okay, so don't limit yourself to horsepower and watts alone. If you have the problem regarding power, voltage, current, resistance, especially the application of Ohm's law in electricity, don't be afraid because sometimes they will combine that there. Okay, you have to correlate and then you can solve for what is being asked. That's going to be the type of problems that will come out in the board examination. Okay, you cannot expect because during in our colleges we'll never, for example, I'll take the subject. We have electricity subject, right, in in college. Okay, we have practical electricity and we study a lot of Kirchhoff's law, Ohm's law, voltage, current, and resistance. Not only for electrical engineer, that's common for all engineering courses. We have electricity subject. Sure, 101% sure. Okay, it's being discussed all the time. The problems always dealing with, current, ampere, voltage, inductance, capacitance, resistance, like that. But they never touch this thing, this calorie, this BTU, this joules. Okay, but what really strange for examinees for engineering courses in board examination, they have a problem like this. Okay, and then the students before are not usually using this kind of units. Of course, you will panic for the very first time you will encounter that in the examination. Okay, that's I'm telling you. You have to memorize this. Not only limited to electricity units, horsepower, watts. It's also applicable for joules, calories, BTU, and erg. Okay, especially if the problem was said the current will pass through the wire. It's 2 ampere in 13 seconds. What is the work attained in joules? Wala na, because your mind are always focusing on watts and horsepower, right? Because that's power, electricity. If you speak about power, your mind will only focus to electricity. No, it's not. You can also focus other thing like this, especially in the energy. Okay, because energy is the capacity to do work. Not only the people will do the work. The wire, the cable also will do the work. Because the wire and the cable has also the energy to produce the electricity. Not only limited to person. Okay, just like also an equipment. The equipment will do the energy, the mechanical energy, okay, to cut this objects or whatever. So they have also the energy. So that machine have the capacity or ability to do work, not only limited to a person. It's same story here. So we are not only limited to the power, which is ohms, resistance, and inductance, okay, like that. There's a lot, right? Resistance, inductance, capacitance, voltage, ampere, current, okay? Not focusing for that only alone, okay? Because in the examination, they will vary the question. This is the time analysis will work, okay? And if this analysis will work, we need to back up with correlation with different formulas that we gained in our high school, okay? Or in the college na siya. But better start na good siya when you, okay, learn this basic formulas because these are all discussed also in high school, but not that in detailed or in complex way of discussing. At least you have now the stock knowledge on your brain cells. Okay. Number 5, power is supposed to work over time, right? Okay, ganon. So bingo na siya. Tutuwaron pa siya, you can solve what is the resistance, what is the voltage, like this, in combination to these energy units. Okay, power is equals to work over time. Let's correlate the force times distance ha. Okay, power, charot. Power is equals to force times distance over time. Oh, this guys, power is equals to force times distance over time because force times distance is the formula of work. Okay, now, charot. Distance over time is a rate. What kind of rate is that? Dun, dun, dun. Let's just we have a quiz ball now, or quiz ball or any kind of contest. What is d over time? Like that. D over time is the rate of change of the speed. Okay, so you can still simplify this equation as power is equals to force times the speed. So we have another formula also for power. Oh my gosh. So there's another, so three formula na siya. Okay, so power is equals to force times the delta change in the distance covered over the time covered, or dt, or distance over time. So let's put this as v, small letter v, speed, right? Okay, like this. Oh my gosh. So for example, you can apply this also in a car moving. If you drive your car, I need to compute the power of my car. So you can also use this formula, force times velocity, or the speed. Okay, so where can I get the force, Sotero? They use another one, okay, force times distance, okay, or use the pressure. Pressure has also force there. Pressure is equal to force over area, okay, and then if you have the pressure meter in your car, then bingo, you have the force. You can get the force because you have the distance covered. You have to measure that one. How many kilometers, and then substitute the force here, so you can compute your power. Okay, so compute the power when you drive the car. Okay, so you can compute really because if there is force, there is velocity. This is distance covered, and then you can, if you get the pressure, then bingo, you can solve. Okay, like this only. Do not limit your formula with work over time, ha. Okay, so in here class, okay, there's three formulas already for power. So work over time, force this times distance over time, and the force times the velocity. Okay, force times velocity. Now take note. Is there a relation to the momentum? Take note. Momentum, because momentum is mass times velocity also. There's a relation for this. And you can create another formula also with power in terms of momentum. I don't have to detail that one. Do it by yourself. Okay, because momentum is equals to mass times velocity, and compute for the velocity and substitute the velocity here in the force times velocity. So you can get also another formula with power. As much as you could, correlate all those basic formulas and you can obtain a new formula. Okay, even though it's not discussed by your instructors and your professors. Okay, that's the technique really, especially in examination. Okay, so there's another way how to solve what is being required. Okay, and then since momentum is equals to mass times velocity, and force also is equals to mass times acceleration, then you can also have the power in terms of acceleration. Okay, at least you can have so many formulas pala talaga siya if you connect the dots. Okay, and because in the second law of Newton, Isaac Newton's law of motion, force is equals to mass times acceleration. So just insert that there also. Okay, and another also thing is the gravitational force of masses directed downward, right? Gravity, acceleration due to gravity. Okay, 9.81 meter per second squared, or 32.2. Okay, feet per second squared, and then apply that here also. It can be applied also. Okay, something like that. But take note, the horizontal distance, the vertical distance, like that. If it is still applicable, that's your assumption or analysis already. Okay, just like that. Okay, so this is the power 1, 2, 3. Okay, bingo. And now we go to the work. Work is already the same. I already discussed that, but I need to introduce another form of work. Okay, aside from force times distance, just still another. Okay, work. Gosh. That's why we have work to earn for our living, because work is very important to earn money. Okay? And when we earn money, then we exert effort. And upon exerting effort, we have the force exerted on our job. So this is very applicable also in our actual scene and working. That's why it is work. Okay? Work is equal to force times distance. If there's no force, there's no work, you cannot gain money. Okay? In your salary. Okay? Because that's force. You apply force on your work using your hands, using your feet. Okay? So that's why it makes this very, very important. This discussion all about. Okay? Okay, what is your work? What is your salary? Charot. Oh my gosh. Okay, my work is dependent on my salary. Charot. And my salary is dependent to my work. Charot. Ayan. Okay. Work. Talaga. Okay. I cannot write without work also. I holding my pen. I speak. I cannot speak also without work. Anything that comes out in my mouth needs force. Okay, needs distance covered by the the air of the words that I deliver to you, and also this ink. Okay, when I write something like that. Okay, so work is equal to ganun siya. Force times distance din siya, no? Okay. Okay. This one. On the spot tayo ha. I did not prepare this. Okay. Force. What is force? So you can color it that into pressure is equal to force of area. So force is equal to pressure times area. So it becomes pressure times area times D. Oh, wow. Perfect for the very first time. Pad. Okay? Ngayon lang ha. Okay, so work is equal to force times distance. Since we know force is equal to pressure times area. From the formula, pressure is equal to force area. So we substitute that there, it will become pressure times area times distance is also a work. Oh my gosh. In terms of pressure and area. Oh, grabe talaga. Okay, you can get, for example, if the question will say, what is the calorie of this fluid gasoline that will go to this pipeline having an area of this one? What is the work? O ganun. So you can still also use this one. Pressure times area times distance. Okay? Horizontal distance ni siya ha, hindi siya vertical distance or the elevation. Okay? Or not the height. So this is a new formula also. Just substitute. Okay? Ganun siya. Pad. Okay? Pressure, area times distance. Okay? From here na siya. Okay. Because you will confuse because at first, force you have no force directly given when she's a problem. So you think of another formula that requires that equation and then correlate that to one. Then bingo, you can solve for the value of the word. Okay. Pressure times area times distance or force times distance. And you will still find another, so many people. Take it individually. What is another pressure formula of pressure? Formula of area. Take note from the pressure, we have also the ideal gas law, right? PV and RT. Also, there's a pressure there. You can substitute that there. It's possible also. If you're taking into account the movement of the fluid, the liquid and the gas, especially the ideal gas behavior, substitute that there and you can compute also. You can introduce another formula also. Okay? That's what I'm telling you. Okay, area. Oh, area. I have also in the volumetric flow rate and the mass flow rate. Then I can also substitute that here. Okay, that's involved velocity. Remember? Okay. Actually, you can correlate all. Actually, it will never be discussed honestly by the professors and instructors all the time. All you have to do is really to have your own efforts to really dig into it. Go to the library, study a lot. Okay, like this. Okay. And then discipline, self-discipline, and adequate and thorough preparation. Okay. Adequate and thorough preparation means a longer period of time to prepare prior to the examination. So that in that stage, you can analyze very well, you can memorize very well, you can practice a lot of problem solving in that period. Okay. And then when the time comes examination, then bingo, you can easily feel comfortable. Charot. Really comfortable talaga siya. Okay. Work. Okay, mali siya ha. And there's another work also, guys. Okay, for the in terms of kinetic energy and potential energy. So work is equals to the change of kinetic energy. Okay. okay, minus the potential energy. Like this, blah, blah, blah. Okay? Okay, this one. Okay? In terms of kinetic energy. And we treat the potential energy as zero all the time. Why? Because it is in motion man good siya. Motion, in movement. So there's no potential energy. Because potential energy is energy at rest man good siya. So there's no changes in the elevation. Steady lang siya ba? Just like me, I'm sitting here in my chair. So, okay, I have the potential energy. I'm not moving, right? So like that. So i-treat na ko siya nga zero ang potential energy when I deal with motion. Okay? Like this. So it will be equal na work is equals to the change of kinetic energy. Okay? Motion man. Okay? It's the energy at motion. So work is equal to the change in kinetic energy. So this means this is change, right? So W is equals to the change of kinetic energy final minus the change of kinetic energy initial. Okay? It's gonna be like that. And this is another formula of work also. Okay? Another formula. So, three na ang formula sa work. Okay? Three formulas of work. Okay? Change of kinetic energy final minus change of kinetic energy initial. Okay? Ganun siya. Then, take the formula of the kinetic energy. 1/2 times the mass times the velocity squared. Okay? Then you can also create another formula in terms of velocity. Oh, ganun siya. Okay? Just have your own correlation and have your own formula. It's gonna be like that, ha? If you want to become an engineer, create your own formula by correlating those formulas and equations. Okay? Like that. That is work. Number 7. Kinetic energy na tayo. Very easy. Okay? Kinetic energy. Guys, number 7, kinetic energy. Right? Kinetic energy is 1/2 mass times velocity raised to the power 2. Ganun lang siya, ha? Okay. Ano siya? Kinetic energy is equals to 1/2 times mass times velocity squared. Memorize. Okay. 1, 2. 60 seconds memorization. Can you make it? Okay. Okay, potential energy is equals to the mass times the gravity times the height. Okay. Okay, elevation kayo siya. Okay. Muna siya. Potential energy is equal to the gravity times the mass times the height. The height here, class, is not the horizontal distance. It is a vertical distance. Kaya nga height A. Okay? So it is referring to height or the y-axis. If you put into graphical representation. Okay, height. So others also will be confused, including me. If I will substitute the horizontal distance, the unit also is an energy kasi that's why. So you will force to substitute sometimes if you will find difficulty. I cannot find the height, ganun siya. So in situations that very difficult also to manage, especially time pressured and time limited. Okay, so my gosh, even though you know how to solve it, you will panic also. Okay, that's another factor also, ha? Okay, so just relax, go over the simple formula. Potential energy is equals to gravity mass times height. Okay, ganon. Gravity, again, 9.81 meter per second squared. Okay, and then 32.2 feet per second squared. So it refers to acceleration due to gravity. Okay, it's not the speed because it's raised to the power 2 man siya. Okay, in the denominator. Okay, so gravity. Okay, some books also are using small a in the gravity. Okay, just remember that one. It depends on the how the discussion in the book presented, and how your instructor also the professor teaches you the symbol used. Okay, but any symbol, it's the same thing. What is important, you understand what is that all about. Okay, number 9, molar mass. Charot, okay? Okay, ang molar mass, guys, is more on chemical engineering point of view and BS chemistry point of view. But it can still also applicable in other engineering because common nga siya eh. We take chemistry, we take physics. We are common for that subjects, all engineering courses. Okay, but sometimes it will be taken for granted for other courses, right? But in chemical engineering course, we'll never take it for granted because mole is very important. Mole or the molar. MOLE is the unit of the amount of the substance in a stoichiometric relationship in the chemical calculations of chemical reactions. Could it be reversible reaction or irreversible reaction? Ganon. Okay, so molar mass. So the molar mass is not really the direct mass, the same as mass. Okay, that we will say. Density is equals to mass over volume. Mass is equals to density times volume. It's not that. Here this is molar mass. So meaning to say it accounts the molar or the mole. So molecular weight. Ganun siya. So molar mass. Okay? Ayun mo katintal if there is the same term. Okay? Inyo siyang i-investigate one by one. Okay, ganun ang technique. Okay, so molar mass ko. Okay? Kakaloka. Okay, molar mass. So, molecular weight, mm lang siya to make it short, mm. Capital M, small letter m, that is the molar mass. Mag-create taog another symbol para madali siya. So, mm is equals to molecular weight times small letter m, which is the mole, M-O-L-E, okay? In chemistry, small letter n is always the mole, ha? That's why we have mole fraction. So mole fraction of component A is equals to the mole fraction of A over to the mole fraction total. So it's just the same here. Okay, so molar mass is equal to the molecular weight times the number of moles. Okay, number of moles is mole, molecular weight is gram per mole. Cancels the mole, what left is the grams. Okay, it's just the same the mass, but another thing lang siya. Okay, it deals with molecular weight. Okay, if compound molecular weight, if element only, single element atomic weight. Okay, that's the difference, ha? Okay, molecular weight ganun siya, molecules. That's why molecular. Okay, atomic weight is atom. It's atom only of an element. Okay, so that is atomic weight. Okay, so the terminologies must be precise also. Okay, like that. If given a calcium carbonate or a limestone compound, calcium carbonate, right? So the molecular weight of each, then total it out. That is the molecular weight to be used in a molar mass. Okay, and then if it is atomic weight, the atomic weight only of calcium, the atomic weight only of carbon, like that, and then break it up. Okay. So that's gonna be like this. But it's here is molecular weight. Okay. For example, what is the molar mass of calcium in calcium carbonate? Oh, break it up. So get the individual atomic weight and times the number of mole. So, Sir Sotero, how can I achieve the number of mole? Then do a chemical reaction. Okay, so decomposition reaction. Okay, calcium carbonate solid is equals to calcium oxide plus carbon dioxide. Okay, then balance the chemical equation all throughout, and you can determine the number of moles for that each in the reactant and product. So use that number of mole for the calcium alone. Okay, and use the stoichiometric relationship there, and then you can cancel like that, and that will be your molar mass because you consider the chemical reaction. Okay. Unless it is specified in the problem that 1 mole of calcium will react to 2 moles of carbonate. Ganon, di ba? So, this is calcium carbonate man siya. But it's not always all the time saying that one. Okay, so that's why you need to break that down in a chemical reaction, even though not stating the number of moles at first. Okay, so cancel the number of moles. What left is the gram. So that is molar mass. Okay, number 10, we have the molar density. Okay, same story. Okay, molar density. Okay, the molar density is not the same with kilogram per cubic meter, or grams per cc, or grams per ml. It is mole in the numerator. Okay, mole in the numerator, but a volume in the denominator. The same. So, sa to pa, if we have the density of water at 4 degrees Celsius, which is equal to 1,000 kilogram per cubic meter, now, our molar density, okay, density tayo, di ba? our molar density of water at 4 degrees Celsius will be equal to mole over cubic meter. Okay? Okay, now, if we have water, example lang siya, compute the molar density of water at 4 degrees Celsius. Okay? So, masolve na to siya. Okay? So, like this. So, molar density. Okay. Molar density is equals to small letter n in the numerator is the number of moles over the volume. This one. Molar density is equals to the number of moles over the volume. The volume is cubic meter, cubic centimeter, liter, gallon. It depends on you, okay? Or what's being asked in the problem. Okay, now if we have the density of water at 4 degrees Celsius or equal to 1,000 kilogram per cubic meter, okay? Metric tayo ha, di tayo English unit system. Okay, 1,000 kilogram at 4 degrees Celsius. Okay. Ako lang yung butang ang 4 degrees Celsius so that you will know that the standard density of water, pure substance pala, taken is always 4 degrees Celsius. Okay, maybe it will come out in the board examination also in examination. What is the temperature reference of the density of water, which is 1,000 kilogram per cubic meter? A, 4 degrees Celsius. B, 5 degrees Celsius. So you can answer already that it is 4 degrees Celsius. No need to scan the book or the textbook because you memorize that. It's already in your brain cells. Okay, so like that. Okay, so the molar density is equals to the number of moles. So moles over, let's say, let's choose cubic meter because we are using a kilogram per cubic meter man siya. Okay, ganun. Okay. Oh, ganun siya ha. Okay, now, we need to find the molar density ng good siya. Charot. Okay, now if that's the case, you have the water. So you have the reaction, involve the reaction of water na, ha? Okay, since you are after for the water man siya, okay, since water is ano man siya, reversible reaction, meaning magtutuwad siya, bali-bali, makaregyapon siya. Okay? Di mo siya maproduce of another byproducts. Okay? Or another compound after the product, right? So, atong balihon. So, ano na siya? H2O, H2 plus O2 plus water, di ba? Usually. So, it could be H2O is equals to H2 plus H2, the reaction. So that we can get the molar density. Example lang. Ayan. Okay, H2 plus O2 is equals to H2O. Okay, this is the first reaction. And then the reverse reaction will be H2O is equals to H2 plus O2. Then balance the chemical reaction. Okay, ganun. So balance na siya. Okay, 2, 2, 2. Okay, and then blah, 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 2. Let's make it direct because water is the simplest reaction of all. Okay, water reaction is the simplest reaction of all natural chemical reaction given by God. Okay, no need to add catalyst. Okay, no need to change the temperature, no need to change the pressure, just because to have this reaction. Automatic na gyud ni siya. That's why we have water to drink every day. Okay, that's natural reaction given by God. Okay, something like that. So this is an artificial reaction that we need to change the different physical properties, the parameters to gain water. It's automatic really. The water is in the planet Earth. We can drink immediately if you want. In the river, in the ocean, like this. Okay? So no additional processes in order to obtain water. Okay? Now in this reaction, guys, there are 2 moles of water. So use these 2 moles in the numerator na. So 2. Okay, so meron na tayong 2, and then a cubic meter, and then the molar density. Okay, now, use the value of this 1,000 kilograms of water. Water maghapon siya. Okay, so 1,000 kilogram, cubic meter. Okay, and then, bali. Okay, cubic meter, moles. Okay, and then, 2 moles. Conversion na gid na siya. Okay? So, mo ni siya may tabo ron. Okay, molar density. Okay? Namatay 1,000 kilograms of water. Kaya water may kamo na itong gigamit, di ba? So the density of water is 1,000 kilograms per cubic meter. So we need to get man siya nga mahimo gyud siyang moles per cubic meter para cancel blah blah blah. Okay. So like this. So we can get the mass. Okay? We can get the mass. So mass is equals to 2,000 kilogram. 2,000 kilogram. Okay? Like this. Okay, since we have density is equals to mass over volume, right? So get the volume so that you can substitute that in the molar density problem or formula. So like this. So density is equals to mass over volume, then volume is equals to mass over density. Okay, and the mass is 2,000 siya. Okay, 2,000. And then the density is 1,000. Oh my gosh, 1,000. Okay. So your volume will be, cancel. We have 2 cubic meter. Okay. 2 cubic meter. Okay. Like that. Kilogram per cubic meter. Cancel, it's cubic meter. So your volume will be 2 cubic meter. Okay. So na naka-volume ng 2 cubic meter is substitute diri ari. So we have the numerator of 2 moles. Okay, so 2 moles over 2 cubic meter. So cancel. So you have 1 mole per cubic meter. So your molar density is 1 mole per cubic meter for water at 1,000 kilogram per cubic meter density. Okay? Using the chemical reaction of water. Okay? There are 2 moles man siya. Okay? So our formula is number of moles over volume man siya. And you have number of moles 2 na sa reaction. And then we have the volume, density, mass over volume, then get the volume. And then to attain the mass is to have this cancellation with each 1,000 kilogram. There's no mass given here. Okay? Since you have an idea that is a molar mass, then you can compute for the mass. Okay? Like that. So it looks like simple, but you have to go on 2 operations. Equation. Okay? So if the question will say, what is the molar density of water at 4 degrees Celsius? Patay. Okay, then some will answer 1,000 kilogram. No, it's not. It's density man siya. I'm asking for molar density. So that means you will use the chemical reaction. H2 plus O2 is equals to water and balance the chemical reaction. Get the number of moles, okay, and use that in your conversion factor. And then get the volume in terms of density equals to mass of volume. Then bingo, you can solve for the molar density. Okay? Ganun siya. Okay? Tintal-tintal ra kayo ang word na density for that. Okay? So, ibig pala sabihin, density is not equal to molar density. Even though there's a term density in the words. Okay? This molar density. So don't be confused. Okay, number 11. Okay. Pressure. Okay. So let's go back with this reaction. We will try water only because water is a reversible reaction with shock. Okay, it will goes back to its natural reactants after the reaction. So that's reversible. So we always use water as an example because water is a pure substance, not siya. With 4 degrees Celsius is our reference. Okay, number 11, pressure. Oh my gosh. Class, memorize na. Get a sheet of paper. Memorize all the value of standard pressures. Now, if you are an engineering student, okay, like that, memorize. Okay, number 1. Pressure in mmHg millimeters mercury, 760. Memorize. Number 2, bar, 1.013 bar. Okay, atmosphere, 1 only. 1 atmosphere. PSI, 14.7. Okay, put in your brain cells, please. Okay, 101,355 Pascal in terms of Pascal because of Pascal theory of gases. Okay. 101,325. And then in kilopascal, simply move to the right, or to the left, sorry, 101.325 kilopascal. So bingo, if you memorize all those pressures, then you can convert whatever you want to what you do. Okay, so now I introduce you the formula of pressure. But before that, okay, I need to introduce a lot of pressure formula. Okay, the first formula of pressure is the force exerted to the object perpendicular to the surface area. So that is pressure is equals to force over area. Okay, that's the first formula, right? The very basic and overused. Okay, that's overused. Even if in the complicated problem, it's still there also. Okay, this is an overused formula. Okay, number 11, pressure is equals to force over area. And then you can connect this pressure also to the work because there's a force man siya. Okay? Like that. So we don't have time to correlate and to derive. So just go by yourself and then create your own formula. Okay? That's gonna be like that if you want to become an engineer. Okay? Like it's a P is equals to force over area. And then pressure also is equals to the density times the elevation times the gravity. This is also another formula of pressure, guys. Okay? Okay. Another also is through applying the Bernoulli theorem, the dynamic pressure. Oh my gosh. Let's prove if it's wrong or not based on only on my brain cells. I remember. Okay, pressure is equals to dynamic pressure, which is equal to 1/2. Try lang niya siya, and let's prove if the unit is pressure also. Okay, 1/2 density velocity squared. This one. Okay, 1/2. Okay, 1/2 density velocity squared or speed squared. This is also pressure, right? Okay, so 3 na siya. So 1, 2, and 3. Okay. This second one, guys, the equation number 2 of pressure is more on hydrostatic pressure, meaning the fluid and the liquid, like this. Okay, and this pressure number 3 is more on the moving body or object. For example, a car moving to a distance of like this. What is the pressure of the car exerted to the road? Ah, grabe. Okay, like that. So that is the pressure in terms of siya sa motion sa mga objects. Okay? And this second also pressure is also more on the elevation sa siya, guys. For example, Sotero dropped an object to the ground and the mass is 2 kilograms. How much pressure he exerted upon dropping that object? Oh, ganon. So even though the mass only of the object is given, I can solve for everything because there's a height of the building. Okay? If there is a height of the building and that is dropping, meaning gravitational force. So I'm using the acceleration due to gravity, which is 9.81 meters per second, and then bingo, I can solve for the pressure. Okay? So what is the pressure exerted by Mr. Sotero in dropping the object weighs 2 grams in a 2-meter height building? Oh, I can solve with the pressure. So that's another way of computation of the pressure. Okay, and then this also movement, kinetic energy. Okay, Mr. Sotero drive a car with a speed of 2 meters per second. Okay, what is the pressure exerted of Sotero in the car? Okay, since there is a velocity, then you can compute also through kinetic energy formula or something like that. Okay, analysis. Okay, and then the pressure is equal to force over area and 3 equations. Now we know the unit I already discussed, right? You memorized that already. I memorized that already, so no more issue. Okay, the height here, guys, is elevation in the second equation pressure. Distance. Take note. Because the horizontal distance also will be substituted. It's still the same unit man siya talaga. Meter. Okay, ganon. Okay, so that is 3, pressure. Okay, now, another formula of pressure. Okay, absolute pressure. 1 meter is equals to Ganun siya ha. 1 meter is equals to 3.28 feet. 1 feet is equals to 0.3048 meter. 1 gallon is equals to 3.785 liters. So memorize the basics, right? So if you memorize that, bingo, you can solve a lot of problems in your examination. Okay? Like that. High school pa lang, memorize those. 1 feet is equals to 1 mile is equals to 5,280 feet. 1 ton, 1 short ton is equals to 2,000 pounds. So if there's no specification that it's short or a long ton, that means 2,000 pounds already. 1 ton is equals to 2,000 pounds. 1 short ton is equal to 1 ton only. Okay? 1 long ton is equals to 2,200 pounds. Something like that. So meaning to say, a long ton and a short ton is not equal unless not specified. If not specified in the problem, that's automatic 1 ton, which is equal to 2,000 pounds. Something like that. Okay, the density of water is equal to 62.43 pounds per cubic feet in English, and in metric, okay, that is 32.2 like this, and 9.81 meter per second squared, the acceleration due to gravity, and the density is 1,000 kilogram per cubic meter. Okay, memorize them all, okay, so that in examination, you can really get the correct answers. If there are difficult questions, then manage your time to analyze, as long as you have the basic formulas in your brain cells. Okay, that is. Absolute pressure is equal to pressure gauge plus atmosphere. And we have also the vacuum pressure. I forgot. The speed of light pala siya. What is the speed of light? The speed of light is 3 times 10 to the raised to the power 8 meter per second. If the question will say, what is the speed of light in a vacuum? Your answer will be 3 times 10 raised to the power 8 meter per second. That is being used in the theory of relativity of Albert Einstein. Okay? Theory of relativity. Energy is equals to mass times the velocity raised to the power 2. Since I already discussed to you already the formula of energy, then equate that there in the work and energy equation, then we can formulate also another formula of energy, okay, by the theory of Albert Einstein. Okay, who discovered theory of relativity? Your answer will be Albert Einstein. Okay, something like that. Okay, please put that in your brain cells also. Okay, now we go to the vacuum pressure. Okay, what is the formula of vacuum pressure? Oh my God. Okay, how can we get that one? So, atmospheric pressure. Okay. Memorize daw. Common kayo ni siya. Ano ni? Sure. Okay. Because difficult only, puno-puno ramang ginang difficult. Pero the basics will be there also talaga siya. Okay. Atmospheric pressure. Oh my gosh. Atmospheric pressure. Sa to pa, atmospheric pressure, guys, is the gauge pressure plus the vacuum pressure. Okay? Okay, don't worry, guys, class, because the vacuum pressure are not used all the time. Because it is a pressure below sea level, manggod siya. Below sea level. So it's not used all the time, good siya. But if the problem will ask for that, then compute using this equation. Plus the vacuum pressure. Okay? The gauge pressure is simply the gauge, okay? That is being installed in the equipment, the measuring device, right? So that is the gauge pressure really. If you put the oil and water inside the tank and there's a gauge pressure, then bingo, that's their pressure gauge of the two. Because they're combining with each other, their pressure is only one. Okay? Because they're combined man siya. Remember Dalton's law of pressure naman. Okay, the total pressure will be the partial pressure of the component A plus the partial pressure of the component B. Our component A is water, our component B is oil. So add it up, that is their overall pressure inside the tank with having a pressure gauge device. Okay, so that's the logic of something like that. Okay, any questions so far? Okay, we have now the absolute pressure, the gauge pressure, the vacuum pressure, the elevated and elevation pressure for the dynamic pressure, the hydrostatic pressure, the static pressure, or simply the pressure applied in exerting an object to a surface area. Okay, any questions so far? Another pressure, please teach me also, then we will incorporate that here also. Okay? Okay, now number 17. Number 12 pa? Okay. If there's no change in elevation class, from point A to point B, our height will be automatically 0. So that's why this kind of energy will be zero na siya. This one. Okay, okay, wala man dyan change ang height. Okay? Elevation pressure man siya. Okay? If you can remember. Okay? So that's gonna be like this. Basta, but if the question will say like this, if Mr. Blank Blank drop object like this, and elevated like this, what is the pressure? You use this one because that's elevated pressure man siya. Okay? Or another term for elevated pressure is the head pressure for head. HEAD. What is the head pressure? Ganon. It's the same as elevation pressure. Okay? But sometimes it will never be mentioned as long as the position of the person is in vertical position already. Just ask the pressure of Mr. Sotero, blah, 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 blah. It doesn't specify, right? If it is elevation pressure, if it is, what do you call this one? Head pressure, like that. But it's understood because it is a vertical position. Okay? So you will never use the other pressure thing. It's this only kind of pressure. Okay? The density, the gravity, and the height. Okay? Ganon siya. Okay? So what else? Kalas. Okay. Number 12. Okay. Number 13, density na. Muna na siyang ingon, the density, which is density is equals to mass over volume. Okay? Ang 12 pala pareho lang siya pressure, so no need to elaborate. Okay, 13, density. Okay. Density is very important in the mass flow rate. Okay. That will go into the system, the feed, going to the outlet. So specifically the energy and material balances. Okay. OMB balances, overall material balances, which are specifically could either be an energy balances or any kind of energy, not limited only to heat energy, mass energy, or water, molar energy, whatever, not limited to that. Okay, density is equal to mass over volume. Okay, so always use this one also, Okay, density mass over volume. So this is more on the volume, so liquid, fluid, and a gas. Okay, like that. Okay, because there's no, the density of the paper. Okay, so if that is the case, if it is a solid substance, normally it is being asked talaga siya. Kasi normally, there's no density given man sa solid. Okay, always fluid, liquid, and gas. Okay, if the problem state in a solid situation, usually it is being asked, what is the density of the calculator if the mass like that drop in a volume of in a pail? So you will use also the buoyancy formula. Remember buoyancy. Okay, you drop this calculator into the water, you will get the force of the calculator. You will get also the force of the water. Subtract the force of the water to the force of the calculator, and then do it again by mass. Okay, mass in terms of mass using the gravity because it is dropping the gravity, and then you can obtain the volume. Okay, and after that, substitute that here in the density equals mass over volume. Then you can get the density of the calculator. Okay, because this density is not limited only to fluid, liquid, and gas man siya. And then rare, it's very rare. The question will ask for the density of an object in the problem solving in any science examination. What if the problem solving examination will ask for the density of the laptop? Okay, what is the density of the laptop? What is the density of the calculator? You are used to liquid, fluid, and gas, rabaya yun siya. Okay, you analyze na talaga siya. Okay, ganon. Okay, so there must be a volume. Ganon. So, what is the volume of the laptop? O length times width times height. Ganon siya. O, siya formula, di ba? Sa mga dimensional. Okay, so you can solve really. Okay, talaga. So, density equals to mass over volume. So, sikot-sikot, nakasolve na already. Okay, now we go to the, ilista. Memorize, put that in your brain cells. Okay, density is equals to mass over volume. Okay, memorize this Dapat elementary pa lang you memorize this one because it's being discussed in elementary science. I think in grade 5 or grade 6. Okay, grade 4, grade 5, grade 6, you already have the basic, the force, the The density, the pressure, the volume. I think so, huh? And then you go to the high school, the same thing story. You go to college, it's expected to be you will become masters of those basic foundations in formulas in science. But what happened? You cannot force all students also to be like that. It depends on the students who are very initiative, resourceful, ganun, ganun. So we cannot blame them also. Okay? Maybe they don't like. They don't like to study those stuffs. Okay? Because they want to study all about money also. Money, meaning financial matters. Their course is banking in finance, business accountancy. They don't have an interest also with that subject. That's why. Okay? It depends on the interest also of any individuals, right? Okay? Since me, I love science. That's why elementary, I will memorize until college. Okay? Because I love science so much. Okay? That's why, like that, and English. Okay, so density is also mass over volume. Number 14, we have the, oh my gosh, the weight. Okay. Question number 1. If you are 60 kilogram on Earth, what is your mass in the moon? Okay, this is a question like it's also in different quiz bowls like this. Okay, you will encounter this kind of problem also. Okay, so your mass and weight is not the same. Okay, because the weight is considering the gravity, the gravitational force pull downward to the earth, something like that. Okay, so mass is not equal to the weight if we consider the vertical fall or distance. Okay, so second law of Newton, what is that? Force is equals to mass of acceleration, di ba? Okay, so force is equals to mass times acceleration. Okay. If the question class will say, blank is the rate of change of velocity, then fill in the blanks. What's your answer? Blank is the rate of change of speed. Okay. Sometimes the question also sometimes like that. Okay. So the rate of change of velocity and the rate of change of speed is simply the acceleration. Okay. Like that. Blank is the rate of change of and velocity. What's your answer? Your answer will be momentum. Okay. Questions like that is very basic. Okay. If you know the formula, then bingo, you can answer. Okay. But sometimes the terminologies matter also. English. Because some students will be afraid. There's a word, a rate of change. Ganon, ganon. If you can remember that a rate must have always time in the denominator, then bingo, you can also understand. Because velocity have time in the denominator. The speed have the time in the denominator. Okay, so bingo, you can understand. Okay, something like that. Okay, okay, you will never say the rate of change of force because the force has no time in the denominator. Okay, so it should always be an energy. Okay, or the power. Okay, because it's work over time, something like that. Okay, like that. So I think let's create another formula. So Newton per second. Is there Newton per over second? What's that? Talaga? So I think nothing. That's why there's no statement that goes like this. A rate of change of force. Because the force will be always applied. Okay? It doesn't dependent on the time. Right? So I don't hear it like that. Okay? So nag-create lang kung ako Wow. F is equals to m times a. So the second law of Newton, right? Second law of motion in physics. So F is equals to mass times acceleration. Okay, magsugod na ta. Okay, mass times acceleration. Okay, papil. I need another page. The formula of the second law of Isaac Newton, which is the law of acceleration. Okay. Okay. So this is applicable class and also in motion because it's second law, of course, self-explanatory. Okay. Mubarog sa ako kay kapoy kay bongko I have a very high stored energy which is a potential energy. Okay. So we have force is equals to mass times acceleration. Okay, guys. This is applicable for horizontal distance. or pushing an object to a horizontal surface. Or, for example, like a car moving in a horizontal, or it could be a circular as long as it is in a ground. Okay, circular motion in an oval like this, in a rotunda. Okay, you can calculate for the acceleration for that. So that's what we mean of the acceleration here. But we have also an acceleration which is vertical. That is acceleration due to gravity. Okay, and you don't have to compute for that. That's standard. I kept on stating that over and over again. So the metric system for acceleration due to gravity, meaning vertical, vertical distance or vertical motion. Anything, as long as it's vertical motion, going downward, going upward, gravity is an issue there. Okay? Please put that in your brain cells. Okay, the acceleration due to gravity will be matter. So 9.81 meter per second squared or 32.2 feet per second squared is our standard values for acceleration due to gravity. Okay, so vertical distance only. Okay, applicable to motion in vertical distance or vertical height, not on the horizontal or not on the ground like this in the circular like this. Okay, you should know the application. Okay, so but apply that here also. So it will become force is equals to mass times acceleration due to gravity. And now since gravity is small letter g, so change this into mg. Ganon. Charot. Talaga. So F is equals to mg. F is equals to mg. Okay. mg. Okay, muna siya, di ba? mg. So force is equals to mg. Okay, acceleration due to gravity. Now, how can I obtain the weight? Okay, so solve for the mass. So mass is equal to force over the gravity. Okay, force over the gravity. In this equation ba, F is equals to mg. Forget sa katong usa, sa katong motion nga car moving like this, like that. Motion, second law of Newton. Gravity lang sakta. Okay, so F is equals to mass times acceleration due to gravity. And then mass is equals to force over acceleration to gravity. And substitute na ta. Okay? So, for example, our force is applied to is 20 Newton. Okay, ganon. So 20 Newton. Okay, again, Newton is equal to kilogram meter per second squared. Right, that here. Okay, kilogram. Ni-assume ta nga 20 Newton. Let's calibrate para maka-arrive yung formula sa weight. Because the weight is not directly manggod siyang makuha gyud siya. There's a direct formula of mass, but there's no direct formula of weight. Class, there's no direct formula of weight, but there's a direct formula of mass. So in order for us to understand well, to get the formula of the weight, we need to have this correlation of this second law of Isaac Newton, of the gravity. Okay, for the reason that we don't have an automatic formula for the weight. Okay, we don't have that. The mass we have. Okay, from density is equals to mass over volume, and from the second law of Newton, which is equals to force is equals to mass times acceleration, solve for the mass. Okay, but for the weight, nothing. And we need to know man yun siya to have the weight formula. So this is it. Okay, so example, I exert 20 Newton. Okay, like this, a force downwards, so kilogram meter per second squared. Okay, like this. And then gravity, 9.81, right? 9.81 meter per second squared. So cancel, 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 cancel. Okay. Ganun siya. 20 Newton or kilogram per second squared divided by 9.81 meter per second squared. Oh, what's left is in kilogram. Okay. In kilograms. So 20 divided by 9.8. Okay. 20. Okay. 20, calculator, guba. Dili kayo makuha na akong calculator. Sorry for that. 20 divided by 9.81. Okay. So 2.04. The mass will be 2.04 kilogram. Take note, mass siya, di ba? Even though I use the formula force, but I can obtain a mass in terms of kilogram. You get it? Okay, so mass siya. Okay. So this is a gravity, right? This one. So this is a gravity thing. So we need to equate that automatically to the weight, this mass that we obtain. Because as I said earlier, the weight must always consider the gravity. So we have an example now, problem, and then we get the mass. So automatically, mass is equals to weight here. So I will put mass is equals to weight. Since mass is equal to weight here, go back again to the formula here. The equation 1 and equation 2. Substitute the weight is equals to M. Okay, so F is equals to weight times G. Okay, and weight is equals to force and G. Okay, this one, you correlate this one. I derive, okay, to let us understand, I derive, okay. So we have an equation is equals to F equals to mass times acceleration from Isaac Newton. And we have also mass is equals to 4 over G. Since this is a gravity thing, for example, if I throw a 20 kilogram object downward and it involves gravity. So we get already the mass, okay, which is 2.04 kilogram. Since that is directed downward, that is the concept for weight. It involves gravity. So technically, we can say in this situation that mass is equals to weight directly. Okay. Then, substitute this W sa mass, pareho na siya in equation 1. So it will become F is equals to weight times the gravity. F is equals to weight times the gravity. And also, weight is equals to force times gravity. Okay, compute for the weight. Okay. So, equation 1, weight is equals to force over gravity. Equation 2, okay, weight is equals to force times gravity. Okay, like this. Di ba pareho siya sa weight? Okay, weight is equals to force over gravity and weight is equals to force over gravity. Okay, like that. It's very clear, right? So, you will solve for the value of the weight. Now, what is the value of the weight? Okay, this one. So this is correct. The assumption is correct because this is a gravitational force. So we can say na ganon. Okay? Force. Okay? Force 1 is equals to force 2. Charot. Okay? Or weight 1 is equals to weight 2. Or gravity 1 is equals to gravity 2. Okay? Ganun siya. Ma-meet mo condition nga ni siya ha. Force 1 is equals to force 2, weight 1 is equals to weight 2, gravity 1 is equals to weight 2 to achieve in equilibrium so that we can achieve this kind of formula. Okay, now, ang mass, asa man nato siya i-colorate ang mass? Mass. Okay, weight. Okay, see. Weight. Okay, we have the mass. Okay, the mass we computed here is already 2.04 kilogram. Okay, and we have the acceleration due to gravity, which is 9.81 meter per second. Okay, like that. Okay. And this is Newton already. This one. Newton, ha? Because kilogram per meter squared man siya. Okay. Okay? Newton. Now, how can we achieve the mass here? Okay? So, our problem now is this. F is equals to weight times G. O ganon. So, since this is mass equals times A. Okay? Very clear that? Okay? Force masa di siya. Okay. Okay. Okay? Very clear. So we can say that weight is equal to M times G. Okay? Like this. Okay? Or let's say M is equals to weight over G. That is grams per meter per second. Okay? Meter per second. And then like this. Okay? Or we can have this aim like this. Or like this. So gravity, so which is 9.81 per second, and the weight which is 2 kilogram. This is also our mass. Okay? Like that. Or we have the weight is equals to mg, and then meter per second squared times g. Okay? Kilogram. So that is Newton. Okay. That's this. Okay? And then this one is equals to 2 kilogram meter per second squared, like this. And this is, so our formula is this. W is equals to mg. Okay? Or M is equals to weight over G. Okay? Malum na. So, muna na siya itong formula sa weight. Okay? So, let's prove. So, mass, kilogram. Gravity is meter per second squared. And this is Newton. Okay. Newton is equals to force. And how can you equate Sotero that the Newton is equals to force? The Newton is equal to force or the weight because it is directed downwards. The weight is just equal to the force. Okay? That's why it is weight is equals to mg. Okay? Malom? So that's gonna be like that. So makuha ra gyud nimo siya is because Newton man gud siya. So force man gud gapon na siya. Okay? So, ganon. So any questions so far regarding weight? Okay? Weight. There's a gravity. Remember that one always with gravity. Okay? And the mass doesn't involve gravity. Okay? Like that. Or you can convert directly and you can achieve the unit what's being required. Then bingo, you can solve for the answer for that. Okay? Like that. So, kasi vertical man gud siya. So your weight will be automatically will be your force siya. But dili mass ha, weight siya. Weight is automatically for your force directed downward and the gravity. Okay? Ganon siya. So that is number ano yun? Force. Number 16. But there's a lot of force also, class. We have the resultant force. Okay, resultant force, the action force, the reaction force. Okay, third law of Isaac Newton. If you have the second law, you have also the third law. And every action, every reaction, there must be equal opposite reaction. In every action, there must have always an equal and opposite reaction. That's the third law of Isaac Newton, right? The first law is whenever a force is acted on an object, it must be acted by a force called inertia. That is law of inertia, the first law. Whenever an object is moving, it is acted by a net force called inertia. That is a law of inertia. The second law will be the law of acceleration. This mass times acceleration to mga motion of the car, ganun siya. And the number three is the law of the free falling body or free falling apple, right? The apple goes down to the ground and it is applied for this one, the law of third law of Isaac Newton. For every action, there must have an equal and opposite reaction. So the force of reaction is a friction. Okay, and the action force is the input force. Okay, input force is the action force. The resultant force is the reaction force or the fraction that will oppose the input force, like that. So that's why we need to have a coefficient of friction to that, so that it will manage to stop when you move an object, something like that. Okay, coefficient of friction, if you can remember. So our force is equals to coefficient of friction times the fraction. Charot. Okay, friction force, because force is the friction, because it opposes the friction, that is friction force, right? So friction force, tabasa ha? I forgot. Oh my gosh, I forgot. So friction force, based on my stock knowledge, okay, wait, 2 minutes to 3 minutes, I have to think. Okay, friction force, blah, blah, blah. Wait. The relationship of the coefficient of friction, I forgot. Wait for a while. Okay. Because I did not, that's a very long time ago, right? So we have, let's say, friction force is equals to, I think, not sure, huh? Research that also for yourself, because maybe I forgot. Coefficient of friction times the normal force. Normal force meaning the force applied on the object. Okay? Kini siya. Bahala na niya, maraming susa ka utok. Okay? So frictional force is equal to coefficient of friction times the normal force. The normal force is the input force, or meaning to say the action force. And this friction force or frictional force is the reaction force. Okay, based on what I analyzed on this one. Okay, like that. So meaning to say this is more on horizontal, right? Horizontal, not vertical, because vertical are having gravity naman good siya. Okay, so it's not applied on the vertical. It's always in the horizontal, such as pushing the table, pushing the chair. So you have a force like that. What is the fraction force? What is the normal force? What is the action force? What is the reaction force? And then find the net force. Net force is the total force balance between the initial and final. Net force. Okay? Output force minus input force. Ganun siya. Okay, output force, input force, and then the output force, it's in there. You consider the coefficient of friction. Tama ba? I think so. Charot. Okay, net force is equals to the output force minus the input force. Okay, and then the output force, it should be the totality man gud siya. Na ni-move na gud siya ba? So, if ni-move na gud siya, it's in there that you will consider the coefficient of friction, right? So, am I correct? Then minus the output force, which is the action force only. That does not involve yet the coefficient of friction. Because it was not yet moving man siya. Tama ba? Initial man, initial. Okay? So it was in the output that it will really move, go in the direction, right? It's not in the initial stage. Because it's resting first, right? This example, so table, resting. Okay? The potential energy is wala pa rin siya ikuan, zero pa rin siya, wala pa man move ang velocity. Pero taas yung potential energy. Okay, kaya nag-stored man siya. Okay, then the same thing also with this fraction thing. Okay, like this. There's no fraction yet. Okay, because it was not move pa man siya. May bawa na mo siya kung i-move nimo, muhunong gani siya, or mo duwit, gahit kayo nimo siyang i-move, that's when the friction is working already there. Okay, that's the time you need the coefficient of friction. Ay, charot. Basta mo na siya, frictional force or friction force is equals to coefficient of friction times normal force. And correlate that also to action force, reaction force, resultant force, net force. Okay? Go to research that also by yourself. Okay? And read a lot about force. Force is very important also, okay, in dealing with liquid gases and solid substances that are moving. Charot. Talaga. Okay. Let's go to moment already finished, right? Number 17. Number 18, speed and velocity is very easy, right? Speed is equals to the distance over time. Okay? And velocity also is the distance over time. But velocity is a vector quantity because it considers the direction, right? And the unit are meter per second or feet per second. Bingo, kalas. Okay? You can solve motion problems now through that. And you have an assumption like this. Car A, car B travels at a time of like this, and a cover of distance like this, and the other car. So you will assume that they will meet on a certain point. So meaning to say the time is equal. Okay, if the time is equal, then you have to say T1 is equals to T2. And then since there is a formula for T1 and T2 in terms of speed, then bingo, you can solve what is being required. So it analyze na siya because at that time man siya mag-meet man siya. So what is the distance covered of car A when they meet with each other? Okay, when they meet with each other, the time is equal. Alangan man. So pareho siya time. Okay, so you can compute for the distance, the velocity. Ingana ra gyud siya. Okay, and then point 1, point 2 equate like this, like this. You can solve already what's being required. That's very easy, right? Okay, speed and velocity. Okay, except for the projectile. You know the projectile throwing a ball and then it covers a velocity like this, and you have to solve for the wait. You have to solve for the force, but considering the angle of inclination. Ganon. Angle of inclination meaning to say angle of inclination from the surface. Di ba? Ganun, acute angle, ganun. Okay, for example, if the force applied and the distance applied, and then it is, diagonal, then your work will be different na. So work is equals to force times distance times cosine theta. Charot. Why cosine theta, Sotero? Because cosine is, ano man siya, on the, nakakaloka, on the x-axis biya siya. If you can remember that one, cosine theta is equals to the horizontal distance over the height. Okay? And then sine theta is equals to the height over the cosine theta. And then tangent theta. Ganun, di ba? Nakiramdam pa mo? Tangent theta is equals to, wait, equals to A over B, the height and the height over the distance. This tangent theta. Okay, cosine theta is equals to the, I try to memorize, remember pala, the distance over the hypotenuse. Sorry, the distance horizontal over the hypotenuse. That is the cosine theta. Okay, the sine theta, the height over the hypotenuse. Okay, and then the tangent theta is equals to the base and the height. So you can compute for the arctangent theta so that you can solve the value of angle. Trigonometry, I try to remember. Okay, then theta is equals to the arc cosine of the base and the hypotenuse, and then sine theta like this. Basta ganun siya, okay? So you can solve for that. The work in terms for if there's an angle of inclination. Ganun. So that's it. So number 19, acceleration is very easy also. The rate of change of velocity and the rate of change of speed. Acceleration is equals to speed over time or velocity over time. Ganon. Okay. And we have also acceleration due to gravity. But acceleration due to gravity is a downward movement. Downward. Okay, vertical movement. But this acceleration applicable to horizontal movement, side movement, rotational movement, ganon, or zigzag movement, random movement, all except for vertical movement or motion because of using acceleration due to gravity. Okay, but still the same formula. Acceleration is equals to speed over time. Ganon. And speed is equals to compute. Okay, number 20. Okay, specific gravity. Number 20 na tayo. Okay, specific gravity. My gosh. Specific gravity of a substance is equals to the density of a substance over the density of water. Okay, if we have a substance with known density, okay, with known specific gravity rather, then we can compute the density of that substance because we have the reference density, which is water at 4 degrees Celsius. Okay, so we can have, even though the density is not given, only specific gravity is given. Okay, so we cannot memorize the specific gravity because so many. Okay, that's why it's not advisable to memorize the specific gravity. Okay, even water, it's not advisable to memorize the specific gravity. Okay, like that. Because just a lot. Okay, at certain temperature and pressure, what is the specific gravity of alcohol or ethyl alcohol? Ganon. Okay, or what is the uh, specific gravity of sucrose? Wow, white sugar. Grabe. Okay, the specific gravity number 20. Okay, I need to cut off this to number 20 lang siya, specific gravity. Okay, and then let's continue the kinematic viscosity, thermal conductivity, theory of relativity, the flux, the rate of transfer, the pressure fraction, the shear stress, the Kirchhoff's law, ano ba ito eh? Dami. Okay, like this. Okay. Ganun lang siya. A combination pala of physics and chemistry. Okay, this all formulas that can be used in higher engineering subjects also involving science. Okay, especially chemical engineering and BS chemistry. Okay, not so much of BS chemistry because they are not usually dealing with mathematics all the time, right? It's chemical engineering. Okay, like that. Because other engineering courses also have only less sciences subjects also compared to chemical engineering. So they can apply only a less of this, okay? But we, chemical engineers, apply a more of this because this is more on chemistry and physics. Though they also apply this, but their higher subjects are not more on sciences, manggod. Okay? For example, electrical. So they are more on electrical man siya. Okay, so parang ganon-ganon. Okay, so industrial engineers, more on industrial siya. Okay, so dili kay siya science. Okay, but for chemistry, and physics, like this. So involved na siya ani parati. Okay, parang ganon siya. Okay, thank you so much for listening for this lengthy live streaming. I hope you get a little bit of information and you can share to your daughter, to your son, to your children. Then if you are a high school student right now, if you're a college student right now, then you are going to absorb the most important part, then you can write that in your notebook, in your sheet of paper like that, okay? And try to practice solving. Problem solving is also related with this basic formulas, okay? Like that. So if you know this all, then there's no doubt you can easily understand complicated and complex problems because all complicated and complex problems involve this also in the formula. Okay, but I advise you do not focus on the difficult and complex problems. Okay, like that. Just focus on the easy, average, and above average, and a little bit difficult. Okay, because the percentage in examination, they are not a fool, FOOL, to give all difficult. Why? Because if they give all difficult, nobody will pass. Okay, that's the logic first thing to do in your mind. So they will just balance everything. Of course, they will give more easy to average or above average, a little bit difficult. They will never give too much difficult. Take that in your brain cells. Okay, because if they will give all difficult, nobody will pass. Okay, so just be positive na lang yun siya, parang ganon. Okay, and treat all problem solving as easy as you can. Mental psychology. Okay, so, I can make this. It's very easy, like even though it's already difficult, but just have a positivism that you can make it, something like that. And what do you call this one? Confidence level. Improve your confidence level, and then aim to become a top notcher. Okay, in every examination, aim to become the number one so that you will pass. Okay, just like that in a competition, right? If you're joining quiz bowls or any science quiz or whatever, you should target to win. Just like that in the examination. Okay, it doesn't mean that you have to win, but that is only your perception. You will land on a higher region of your thinking capability. Okay, I aim to become a top notcher, then I passed. Of course, because you have a very high aim. Because if you aim to pass, you will fail most likely. Okay, and honestly, I do it when I'm taking up the chemical engineering. I want to become a top notcher. Okay, really, I don't have to be arrogant, but I tell you honestly, I do that in my mind. Even though I'm not as cum laude or whatever. Okay, I have that perception that I want to become a top notcher. Okay, and then I passed. Okay, because if I aiming for a pass, maybe I fail. Something like that. Okay, so aim high. Something like that. Okay, for all those examinees now, especially chemical engineering students, 2021, your board exam will be on October 2021, right? Okay, please do a lot of, memorization, practice solving problems like that. Please memorize this, please. Okay, all like this. It will really come out. Okay, this all. There's 30 formulas. Okay, and then memorize also, guys, the laws. Laws, for example, Arrhenius theory, okay, Le Chatelier's principle, mga ganun siya ba? Mga Fourier's law of conduction, Newton's law of viscosity, Bernoulli theorem, mga ganun. Law of conservation of energy, law of conservation of mass. Understand that, okay, because it will be used in the complex problem solving also. Okay, and then memorize the different kinds of laws and theorems, the Dalton's atomic theory, the ideal gas law, the law of Pascal pressure, okay? The Dalton's law of partial pressure. Dalawa pala siyang Dalton. The Dalton's law of atomic theory and the Dalton's law of partial pressure. Dalawa siya, ha? Okay. Charles' law, Gay-Lussac's law, Boyle's law, the non-ideal gas law of van der Waals equation. Okay? Guys, if you're a chemical engineering, do not just focus on the ideal gas. There's also real gases and non-ideal gases. Memorize the van der Waals equation. Okay? Because not all gases will behave as an ideal gas. Okay? Like that, put that in your brain cells also. Okay? But admittedly, most will come out are ideal gases, but we don't know if there are non-ideal gas or real gases that will be in the examination. Then you don't have the formula of van der Waals equation. What will happen to you? Because you cannot force the PV and RT to be applied in the non-ideal gases or the real gases. Okay? So there, a little bit difficult because you have to consider the fraction factors, like this, blah, 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 so on. So, and the equation is more complicated compared to the PV and RT, which is the general gas law equation and the ideal gas law equation. It's more a little bit complex, and I think that's the main reason that it's not mainly discussed also, because it's not common every time. Okay, but we don't know also this examination, because expect the unexpected talaga siya. Okay, and then please also memorize the concept of the periodic table. Okay, the relationship, because it will also come out in the physical and chemical principles, especially on the what happened to the atomic radius. For example, only atomic radius of calcium. Which of the following has a high atomic radius? Calcium, bromine, xenon, krypton. Or if you don't have an idea, then what is that? So you will refer to the atomic number, to the mass number, to the number of protons, to the number of electrons. You can open the handbook and check the behavior. If it will go to the right, if it will go to the left, what will happen to the atomic radius? If the atomic number will increase, what will happen to the atomic radius? If the electronegativity of that element will increase. Hanggang ganun siya. Relationship. It will help a lot in the theory. Okay, because I think so there are 70 to 60% theory, only 30% are problem solving. Something like that also in physical and chemical principles. Not all problems really. Okay, so you work more on the theory. Okay, if you perfect the theory and you are not good really in problem solving, just like me. I'm not really good in problem solving. Okay, I'll just cover up with the theory questions. Okay, and admittedly, I can also solve some problems. Okay, plus the theory, then bingo, I can have a little bit high score. Okay, but admittedly, I'm not good really in problem solving. Okay, so if that is the case, I am not good in problem solving, so I fail. But why I'm not failing? Because of the concepts and theories. Okay, and the theory is more on me rather than on the problem solving. Okay, and it happens also that there's a lot of theories and concepts that will come up in examination, only for 30-40% problems. Okay, but it doesn't mean also that I cannot solve those problems. At least I can get 2 or 3 out of 8, then add with the theory, then it will pull up my score. Okay, so but my point is work more on the theories and concepts and principles, and then practice solving problems. Okay, like that. Do not focus on the difficult part because it's not all difficult. Okay, like that. So just relax and follow the technique first. Solution, given, data. Hanggang ganon. Check the applicability. Hanggang ganon. And then what is the applicability of the formula? Then use it. Okay, ganon lang siya. But admittedly, class talaga siya. There will be a time that you can make your own formula because you feel it is not discussed really. Okay? Okay, that's the difficult part. But not all. I think only 5, 4 items, 3 items like that. And you use all the formulas, but still the answer is wrong. And then you have to repeat again. Then make your own formula. What I mean with make your own formula, meaning you correlate all the formulas here. Okay, and then derive another formula by having a clear assumption that it is equal among the other and using the theories like this. Sometimes it will be combined, liquid, gases, and solid, blah, 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 so on so. Okay, especially in the heat transfer, momentum transfer, ganun siya. And not so much with distillation because it's always like that. Okay, but this heat transfer and momentum transfer really can, connect with each other. Oh my gosh. Okay? So, be careful. Ganon talaga siya. Okay? And then for the mathematics, guys, memorize na lang yun siya ha. Ang integral. Uh, I1 to I27 ba na siya? Memorize na lang siya. Ay na lang isagad na lang. I-memorize ang differential. Tanang formula, i-memorize na lang siya. Okay? So that no more headache. You cannot expect that to be found in your handbook. Okay, because it is a general engineering. Okay, guys, thank you so much for watching this discussion regarding basic and common formulas of sciences or science that will be used in your higher engineering course subject. Thank you so much. God bless everybody. Bye-bye. If you are not yet subscribing my YT channel, then you can subscribe and then you can comment down below in the comment section and then you can like whatever, you can share whatever, and then click for the notification bell from newest updates of MSA right now. Bye-bye, guys. Bye-bye, everybody! Charot. Grabe, taas. Ang haba. Ang haba talaga ng discussion. Mauubos talaga ito. Charot. Talaga.